This is Candid Campus, Profiles in Higher Education, presented jointly by the Higher Education Alumni Council of Oklahoma and the Oklahoma College Public Relations Association. The discussion today is on computerized engineering. Your host is John Crump, Director of Development and Alumni Affairs at the University of Science and Arts of Oklahoma.
Hello and welcome to Candid Campus. Today we're at Oklahoma State Tech in Okmulgee, Oklahoma, right in the middle of a commercial art classroom. We're going to be talking about commercial art at Oklahoma State Tech, as well as looking at some very sophisticated computer applications that they're using in the programs here at Oklahoma State Tech, and we're going to be visiting with various faculty and representatives on this campus. Our first guest on the program today is Larry Rose, who's instructor in commercial art. Larry, welcome to Candid Campus.
John, thank you very much for coming. We appreciate your being here today and talking about Oklahoma State Tech.
You know, Larry, when I think of art, I think of the Mona Lisa, and that sort of typifies art to me. However, I don't think that's quite what commercial art is all about, is it?
No, if you have to wait as long as the artist had to wait for money on that one, I think these guys had all starved to death. Commercial art is really graphic design, if you will. The creation, design, and the execution of pieces that will end up in reproduction in some way. The Mona Lisa is reproduced on occasion, but these people design and produce things that will end up in print media advertising, collateral material, brochures, and so forth.
Let's give the viewers some examples of what we're talking about. I see lots of things on the wall around here. Let's look at some of these and explain how a student goes about developing these.
This particular class is the sixth trimester, or the final term in their 2-year curriculum, and they have just finished a senior project, which is a corporate or product identity. What you see is examples of many of the students' work. Specifically, you'll see some things like stationery. You'll see sign systems, you'll see ad campaigns, you'll find some brochures, some sign systems, and so forth. As you look around the room, you'll find that there's a variety of different kinds of work. There's a theme park, there's a computer software company, there's a housing development, there is several restaurants, there's a jewelry store. Each of the students had to research the project. They're all theory, if you will. They didn't pick an existing business and then create it. They had to create the business and write the logistics for it. They had to decide who their market was. They had to decide the approximate or the style of location where this particular business could function, and then design all the graphic material that would go with it, from the basic form work clear through the final signs, and in some cases even the exterior of the facade of the building, but not the structural portion.
Now, this sounds like it's a very complicated process in terms of getting a student to the point of where he's capable of doing this. What does a student go through to develop this skill or expertise? Is it a natural artistic talent that the student has, or is it something that's totally taught in the classroom here at Oklahoma State Tech?
The school philosophy is to accept anyone who wishes to come. So we get students at the beginning of the program who have had absolutely no training, and some with a great deal of training. We make an effort and do a fairly good job of teaching them the skills that it takes to do the kind of project that you see here. Some of the people in this class started with absolutely no previous training and have done an excellent job. I think the overall product or grade average in this class was somewhere around a 3.5.
Well, speaking of background, let's ask about your background. Where did you get your training in commercial art, and how did you work your way into this position here at Oklahoma State Tech?
I went to university and I didn't graduate. I went out and got a job. The best job I was able to get, because I didn't understand production, was I took a job as a draftsman for a short time and then worked into a technical art department in a large corporate art group, the Boeing company, doing charts and graphs. We went from there to freelancing in Oklahoma City, trying to make a living as a commercial artist. And I ended up as a staff artist for an ad agency there, and that was in 1965, I guess. And I have been in the art business in ad agencies and studios until '76 when I came here.
Larry, I understand they're applying some modern technology to what you're doing here in commercial art. How is the computer related to this area?
Well, as I mentioned, one of the first jobs I got to do was charts and graphs. They're boring. The artists get hired to do charts and graphs, but it isn't the kind of work that they want. Now, the computer is beginning to take over those functions and doing a very nice job of it. The computer itself can be anything from an inexpensive, say an Apple computer, which we have in this classroom, up to a $150,000 CAD/CAM system. But what the computer is able to do is the redundant task of things that are not terribly creative, but need to be done. Usually they're used for management visualization, showing product flow or sales curves and so forth. And the artist doesn't really want to do it, but given a computer, he can turn out 6 or 7 times as much work in the same time.
Can we see an example of how this works?
Yeah, we have an Apple computer here in the classroom. Why don't we take a look at it?
Thank you.
John, let me introduce you to Tim Mazer. Tim's from Chicago. He's been working on a project on the Apple II computer. It's his corporate identity logo that he did for his senior project. Right now, it's simply a slide. There's no motion to it or anything.
Okay, Larry, thank you very much for joining us on Candid Campus and showing us around your commercial art studio. Tim, hello. How you doing today?
Not too bad.
Now, I understand you've taken some artwork here, this hovercraft design that you have drawn, and you've transferred this to the computer. How do you go about doing that?
With data statements, numbers, point-to-point drawing.
Data statement, numbers, point-to-point. Does that mean you've told the computer to draw a line from point A to point B, or just exactly how do you do that?
Yeah, that's about it. Just A to B, X, Y plotting.
How long does it take you to draw something like this on the computer?
Not too long. You got to write it out first.
You got to write it out and tell the computer what to do, then you simply punch up the buttons and it does it.
Yeah, I can show you an example.
Okay, I'd like to see that.
That's what I wrote.
This is the program that you've written, and what does that turn into? A hovercraft speedboat. Now, this is fascinating. Does this mean that if I learn how to operate the computer, I can become a commercial artist?
Maybe.
Tim, thank you for joining us on Candid Campus today. We're going to be looking around at some of the other areas here in the Commercial Art School at Oklahoma State Tech, and we're going to go across the hall to visit another studio. We're in a design studio here at Oklahoma State Tech, and I'd like to introduce the Candid Campus audience to Tony Grisham. Tony, welcome to Candid Campus. Tony, there's a tremendous amount of beautiful artwork up on the board, and what is it that the students do in this class to generate this type of work?
Well, this is an example of an outdoor board, and an outdoor board is one that's going to be shown along the highways in the city.
Now, it looks like this is a very small design here. Do the students have to think in terms of a gigantic billboard when they're laying out this basic design?
No, they must think in terms of readability at a distance. That's the first thing they have to think about. They have to think about their type being readable at a distance. They get lectures on that, and then they have to plan where it can be read and have a good push at a distance. In fact, what a good billboard will pull you into it. That's the idea. This one is a good example of a finished piece for this particular course. And a lot of professionals think that this is done with airbrush. Well, what is airbrush?
What's an airbrush?
Oh, okay, airbrush is just a simple it's a machine that blows paint out in it gives it a beautiful finished patina.
Okay.
And instead, they have used pastel, which they've rubbed in with their hands. And then they'll maybe rub 2 or 3 coats in, and it's very clean. And they can do either a solid blue, or as you see here, it's been rubbed in, which gives it that airbrush feel.
Now, this is very interesting, the board here. What does this represent?
A girl from Thailand did this. She came here last try, and she designed her own type, whereas this board at the top, they picked type out of a catalog. She designed her type and designed her illustration and colored them together.
Now, I know our audience is probably curious. What does this say?
Yamatoi. Excuse me.
Yamatoi. So evidently she's designed a billboard for a restaurant in the Orient. That's one of the things you mentioned. The student has drawn this type freehand, and this type's been selected out of a catalog. The students have option of drawing their own type, designing new type styles, or?
Yes, they do. Here's an example over here, if you want to look. This is one of the problems they'll do where they design their type completely, and they must do that. They have to use type, and they'll come down off the line, they'll drop little areas in, and then they have to use different gray and black areas with their type.
So they basically design a new alphabetical type style?
Yes, they can design type by the time they get out of this try.
I see a student here who's working on a design. Is he designing his own type, or is he going to use something out of a book?
What about it, Robert?
Well, this design's mainly out of a book. We're getting ready for production and newspaper. This is a newspaper ad right here, Simon.
A newspaper ad concerning an antique auto show. This student is Robert Lang from Oklahoma City. Robert, why did you select the design program here at Oklahoma State Tech?
Well, I've been to one other art school in Oklahoma, and I've asked professionals around Oklahoma City, and they all said they would rather look at artwork from students from Oklahoma State Tech than any other school because they're more well prepared and they're more serious about their education.
Well, that's a pretty good recommendation. Now, as I understand, you'll finish a program here in 2 years, going year-round on the trimester system to get an associate's degree in art. Is that correct?
Yeah, I'm in my third trimester right now.
So you have another year to go, and do you expect to become a fully employed professional when you finish the degree program
No
here?
doubt. Yeah. I'll go right into it.
Okay. These are rather nice drawings here of some antique cars that you've done. Is this for the newspaper ad also?
Yes. Preliminary sketches for this here, just to give me the flavor of the ad.
Tony, what are some of the other things that students get involved in design class that perhaps we haven't discussed up to this point?
They have to learn to render type by hand, visually, where they can handle a quick layout. They have to be able to do nice line drawings with style and flair. They need to be able to do photo indications. They need to be able to do line illustration. They have to do fashion. They're going to do product ads. They're going to do travel ads. A lot of figures, a lot of faces, and then they have to design SIGs, which are SIGs and logos, which are designs for a corporate image where you do the little bitty designs like, say, Westinghouse, the W for Westinghouse, or the cotton symbol. You've seen it, I'm sure. Since we don't have an example here, I don't.
Okay. Tony, thank you for visiting with us. We're going into another lab here at Oklahoma State Tech, and we'll be visiting with Gary Borsch about some other production topics in commercial art. We're seeing a lot of students at work here today at Oklahoma State Tech. We're in the final production studio in the commercial art department, visiting with Gary Borsch, the department chairman. Gary, welcome to Candid Campus. Gary, what's your academic background?
I have a Bachelor in Fine Arts from Phillips University and a Master's from Oklahoma State.
And if you've been working in the professional art field before you came to work here at Tech?
No, I came directly to Tech out of college and started teaching.
Well, that's interesting. What are the students doing here in the final production studio?
All right, in this studio, their responsibility is to learn basic production art and mechanical art. When we begin that, we start by learning basic hand skills in using mechanical instruments such as drafting tools like T-square and triangle, the mechanical tools like a ruling pen and technical pen. They are dealing with trying to be very accurate in their work. As they build up these hand skills, we work from the more simple problems up to more complex. And when we do the complex problems, they are involved with first creating a layout and then taking that layout and producing what we call a mechanical art or paste up. Now, the objective there is that they create the idea and then prepare the artwork, and then in turn it goes on to be printed from here. In doing that, we prepare artwork for the school here, and we actually, all of our recruitment materials out of house and in-house, we prepare here. The students deal with different people on campus, department heads and administrators, and learning what particular project needs to be done. They will in turn prepare a layout and then prepare the finished art for that project.
So the students are getting practical on-hands experience starting from the beginning and carrying out a project that's ultimately going to be in print.
That's correct, and they actually get to go over in the print shop and see it being printed and get the good experience from that.
Okay. Gary, I've seen a lot of students at work here today. Where are these students going to go to work?
Our students are employed by advertising agencies, by art studios, by in-house art departments in large corporations. In the Oklahoma area, we have most of our students go to work in either Tulsa or Oklahoma City. We have students also working outside of Oklahoma in Dallas, in Fort Smith, in Joplin, Missouri, and in other neighboring large communities.
One thing I'm curious about, maybe the audience is too, we know that the program here at Oklahoma State Tech is a 2-year program where the students receive an associate's degree at the end of 2 years. Do a lot of these students go on to complete a baccalaureate degree at another institution?
Actually, no. Most of them go right on to the job. We have a little different situation here where we have a lot of students come to our program with a baccalaureate degree, and even occasionally have some people here with a master's degree.
So they're here picking up technical skills that they're going to take right to the marketplace.
That's correct. They have found sometimes that they cannot find a suitable job in commercial art without the production and knowledge that we give them here.
Okay. Gary, thank you for allowing us into your studio. We're going to take Candid campus across the Oklahoma State Tech campus now, and we're going to visit a $600,000, that's hard to say, a $600,000 computer, and I understand it's been rehearsing for us all morning, so we'll take you to visit that in just a few moments. Before we look at Oklahoma State Tech's new $600,000 computer, we're in the Computer Graphics Center where the more basic courses in computer drafting are taught. This is Stan Strecker. Stan, welcome to Candid Campus.
Thank you.
What do the students do in this area?
John, in this area, we try to familiarize the students with what a computer is, try to get the students to feel comfortable at sitting down at a terminal, and to do some basic computer programming. The students in this course are writing programs into the computer by the use of the keyboard. From the keyboard, we can send this drawing to the plotter and have an actual drawing or an actual hard copy over here on the plotter.
That's fascinating. Does this mean that computers are going to replace the draftsman sitting at a table?
No, we don't feel like they'll ever do that, John. We feel like that there's going to be a need for both of these people in the industry in future, and especially some of those that you're going to see in the next room.
Okay, thank you. We'll go next door and look at the new computer. We're here in the Drafting Technologies Department at Oklahoma State Tech. This is Don Wells. Don, welcome to Candid Campus. I understand that you have a very sophisticated piece of equipment in this department.
That's true. We're in the CAD/CAM Center at Oklahoma State Tech in the Drafting and Design Department.
Okay, what's CAD/CAM Center mean?
Okay, the CAD/CAM is an acronym meaning Computer-Aided Design and Computer-Aided Manufacturing. The system we have here is capable of taking it apart from the designer's concept into the actual completed product.
How does one go about programming this piece of equipment to do something like that?
Okay, the the operator uses the computer system that we have here. And the computer system consists of several parts. I might describe them first. We have a central processing unit that has 512 K of memory, and attached to that is a disk that has 300 megabytes of storage. There's tape drives and associated peripherals with this computer.
Let's translate 500K and the megabits into something that I can understand.
Okay, 500K would mean 500,000 bytes of information, and a byte is a character or a letter, A, B, C, so forth. So we can have 500,000 letters actively in the memory at one time, and we have access to 300 megabyte, which is 300 million of these letters. The system is quite large, is what we're saying, and it's capable of storing a lot of information.
Okay, so you could conceivably design many products on the system, or a major project that would take a lot of information.
That's correct. And the student can use the system by interactively talking to it through the menu board that we have here. He can put his pen down on any of the areas that are lettered in, and that is a complete command. Rather than type them in on the keyboard, which is kind of time-consuming, it's much quicker for him to put his pen down and pick up the points or the commands off of the tablet.
Now, are the commands on the tablet something that you have designed here, or did this come with the computer?
Yes, we've designed it here. Each operator in industry will have his own tablet designed to his specific needs and his specific type of work. If he runs out of commands, doesn't have a specific command on the tablet he wants to use, he can enter it on the keyboard.
Okay. Can you explain a little more in detail what the students are doing on this particular system right now?
Okay, they're creating the geometry for a model of some kind. I'm trying to see what it is that will allow them to create this part or to make a drawing of the part. The first step is to create the model. We have to have the geometry of the part accurate before we can go ahead and finish the drawing. And that's what they're doing. They're creating a model here. And after they get the model completed, he'll go to the drawing mode and make it look like the engineering drawing that we're used to seeing.
Okay, how's he going to draw it? Where is it going to be drawn?
Okay, he will, once he gets the part detailed like he wants it, he will store it on the disk, and at any time then we have a large plotter here that he can plot the actual drawing out.
Once this is, you mentioned computer-aided manufacturing along with the computer-aided design. What is the next step in this process?
Okay, after we get the design and the model created like we want it, we have the detail, we can then call in the numerical control machinist, and he can structure his tool paths using the same computer, using the same model, off the same database that's stored on the disk, and he has the same information to work with as the designer. He drives his tool paths around the part. He can run the tool paths on the computer before he ever takes it to the numerically controlled machine tool, and he can actually know whether the part is producible, whether it'll be a working part or not, before he cuts his first part on the machine tool.
So this machine will do a lot of the testing that one had to go through previously by hand?
Yes, it eliminates a lot of the prototyping we've had to do in the past and experimental runs. We can do many design iterations on the machine, where before we could only do one and have to produce a prototype, find the fault with the prototype, come back, redraw it. Now we can find the fault as we construct it. The machine will actually check for many of its own errors. If it finds a mistake in the geometry, it will flag that error and tell the draftsman. He can correct it there and be prepared to make the corrections he needs.
So this will save time, money, and energy on the part of business and industry.
It certainly will. It's one of the greatest productivity tools we have. We can expect a 6-to-1 increase.
6-to-1 increase. In other words, if it would take 6 people to do something, this machine will take the place of those 6 people?
The machine won't replace the 6 people, but it will allow each individual to do 6 times as much work.
That's good. Don, we thank you for sharing your time with us here, and we're going now across campus to visit with one of the senior administrative officials here at Oklahoma State Tech. We're in the office of Ed Darby, Associate Director of Academic Affairs at Oklahoma State Tech. Ed, welcome to Candid Campus. My first question is, what does the future look like for Oklahoma State Tech?
Well, John, we're very excited about the future of Oklahoma State Tech in that we feel that this institution, having a single mission of carrying forth Oklahoma's need of educating industrial and engineering kinds of technologists, that we're in a position here by having that single mission, been able to address the computerization, and this, by many experts, are calling this a revolution. And we feel rather confident at this time at where we're at and taking this leadership and carrying forth for the best interest of this state.
Today we've been primarily looking at the art and drafting areas on the campus, and we've seen students using a T-square and pencil, and we've seen students using a $600,000 computer. My question is the computer eventually going to enter into every area of academics at the Oklahoma State Tech campus?
That's a real good point you're making, because you've caught us in a transition, and I think that in itself, T-square and pencil and a CAD-CAM system exemplifies this change, this rapid evolution that we're into. And indeed, the future lies in the productivity crisis, that we will have more and more and greater need for students to become computer literate. It's not to say that indeed we will destroy the T-squares and pencils, but I can assure you they will be of lesser need in the future.
Isn't it going to be tremendously expensive to computerize the whole campus?
I'm not even sure tremendous is an adequate adjective to that, John. I think it's just simply going to challenge all of us to find the resources, not only through our state government and the federal government, but through the support of industry, which fortunately Oklahoma State Tech has been well endowed with this kind. But we've got to have more, and yes, there's no question that it's going to take considerable funds to meet this challenge.
What are some of the specific plans for the immediate future in terms of increasing the technology at Oklahoma State Tech?
Well, we have several, and I would like to say that indeed we have been identifying these for some 2 or 3 years. It's not something that we've simply said, now we need to get involved in computers. But let me just hit some general areas here that we're presently involved in and that indeed we must expand much further. Computerized integrated manufacturing. This covers a broad canopy of numerical control machining, which Oklahoma State Tech has been involved in now for over 10 years. Computer-aided design, computer-aided manufacturing, we've just mentioned that $600,000 electronic computer marvel. Robots are coming. In fact, we have on our campus an educational model, and it's just the beginning of a whole generation of robots that will play an important role. Information processing. This is an area that is going to, again, evolutionize business education. We're talking about the electronics office of the future. If you can imagine, not just word processing, but voice synthesizers that will literally, as we talk, convert that into the written page. The smart dictionary packages, they won't let us misspell. Goodness knows that'll be an asset for me.
I need one of those.
I need one now, quickly. Electronic mail processing, the accounting, the inventory, the filing, the microcomputer, the CRTs, all of this towards office management. Microelectronics, we've been in this for some time. We feel like we've taken and have a leadership role, but the microprocessor applications are everywhere. They're on your washing machine.
Ed, I'm sorry we don't have more time to explore these areas. It all sounds fascinating, and we know that we can look forward to Oklahoma State Tech being a leader in the future in technology in Oklahoma. We hope you've enjoyed your visit to Oklahoma State Tech in Okmulgee, Oklahoma today. We invite you to join us again next week for Candid Campus.
Candid Campus is presented under joint sponsorship by the Higher Education Alumni Council of Oklahoma and the Oklahoma College Public Relations Association. This is the Oklahoma State University Educational Television Services. Candid Campus is presented under joint sponsorship by the Higher Education Alumni Council of Oklahoma and the Oklahoma College Public Relations Association. This is the Oklahoma State University Educational Television Services.